We are going to be looking at soil and all the calculations in soil, but we are going to do that with past questions. So as we'll be talking about the soil, we'll look at past questions under soil and all the calculations. You know, the calculations in soil will be calculating percentage humus, percentage water, and other ones. So as we get there, we'll do that. So we know that soil is the topmost layer of the earth crust, true or false? So soil is the topmost layer of the earth crust. And we know soil is a mixture, right? Soil is a mixture. And we have 3 types of soil. And they are sandy soil, clay soil, and what? And loamy soil. Now, sandy soil, we said it contains how many percent sand? 80%. So you see, you know, sand is a compound, not a mixture, right? Sand is a compound. It is soil that is a mixture. So you see that the major component of sandy soil is what? Sand. So it contains 80% sand. Then less than 20% of, we have humus there and other organic matter. So the major component of the sandy soil is sand. Now let me ask you a question. Do you think sandy soil will be porous or will not? It will be very, very porous, right? Look at it this way. If you have something like this, this is a sand. Since the sandy soil is composed majorly of sand, you see that there will be spaces in between, right? The spaces in between. So what do you think about the drainage system? Will it have good drainage or poor drainage? Good drainage. What about aeration? Will air be able to penetrate through? Good. It will have good aeration, right? But what about capillary action? When we talk about capillary action, we're looking at rising of water in a narrow tube. Take it that way. If you have something like this, a tube, you have a basin here, you have an inverted tube, and you have the sand inside now. What will happen to the rising of the sand in this tube here, in this capillary tube? Will it be high or low? High. In sandy soil, what happens to the capillary action? Is the capillary action high or low? It's low, because what now? This thing is so porous, it cannot hold water for a long time. So as the water is trying to climb up, it will be falling back because this thing cannot hold water for a long time. So the capillary action in sandy soil is low. It cannot hold water for a long time. So since it cannot hold water for a long time, it's not even good for plant growth, because plants require the water, right? But this sand cannot hold water for a long time because it's very porous. As the water, after rainfall, as the water settles down, before you know it will just sink down, right? Because the soil cannot retain water for a long time. So that's that about sandy soil. Now, the second one here is clay soil. Now, the major component of clay soil is what? Clay soil is what? Clay, right? The major component of clay soil is clay. And for those of you that have seen clay before, you agree with me that clay is very sticky. Yes. It's very sticky. If you allow it to dry, you see that it will be very strong, right? Yes. Now, clay soil, what do we say about the capillary action? Now we've known that capillary action, we're looking at how water rises in the sand. First of all, does it have good drainage system? It does not have good drainage system, right? The particles are stuck together like this. Be visualizing mud. Visualize mud in your eyes. You see that the particles are stuck together. Water cannot even penetrate, cannot pass through like that. It's not very porous. The drainage system is bad. What about the capillary action? Can water rise in it? It has the best capillary action because since it can hold water, you know, it can hold water for a very long time. So since it can hold water, the water can rise up the tube. So clay soil have the best capillary action, but it is very difficult to cultivate because if there was water in it and it dries, you agree it will be very hard to cultivate. Good. So is it good for plant growth? It's not good for plant growth. But now the best soil for agriculture, the best soil for plant growth is what? Loamy soil. Loamy soil combines the good properties of sand and clay. It has particles of intermediate size. Particles of intermediate size. The aeration is good. The drainage is good. Capillary action is good. But the one that have the best capillary action we know is what? Clay soil, right? Good. So these are the three types of soil. So we'll be looking at past question on just this. Then we'll go into calculations as related to soil. So I'll be reading out the question and I'll point you to answer as usual. All right. So the first question, I'm using left hand rule. For those of you that will be following online, I will not point you and I cannot point you, so just be following. Be using left hand rule, meaning I'll start from you, then I'll start from you, then you like this, then be going like this until I exhaust all the questions here. I will not take calculation questions yet until we get to the calculation. So let's see questions. You can see this JAMB past question. All right. So the first question here, say the figure below, I'll draw it, represents an experiment with two types of soil. Let me draw the figure. It says the figure below represents an experiment with two types of soil. Then you have something like this. No noise, so nobody should answer until it gets to your turn. You said? Don't worry. So, yes, the question says the figure below represents an experiment with two types of soil. Full stop. The experiment demonstrates dash. The experiment demonstrates dash. So without the option, this experiment demonstrates what? It demonstrates capillary action. Two of us. Two. A says soil attraction for water. B, soil porosity. C, soil capillarity. D, drainage capacity of soil. So it's what? Soil capillarity. Remember when we talk about capillarity, capillary action, we're looking at the movement of water, right, through a narrow tube, right? Now this is a narrow tube, the capillary tube. Water is moving up like that. See this one, the water has gotten to this level. This one is this level. This one, the water is already here. So the movement of the water up this tube is called the what? It's capillary action, right? So this one is used to test capillary action. Do we get? Yes, sister there. Your question. Which of these is not a type of soil? A, sand. B, granite. C, loam. D, clay. Granite. So granite is not a type of soil, right? Yes, your turn now. If three 30-centimeter lengths of glass tubes are tightly packed with clay, are you listening to the question? If three 30-centimeter lengths of glass tubes are tightly packed with clay, sand, and loamy soils respectively, that is, you have something like this. 1, 2, 3. And this one, say this is sand, clay, and loamy soil. So if three of these are tightly packed with clay, sand, and loamy soil, so clay first, clay, sand, and loamy soil respectively, and then stood in a beaker of water for 1 week, the level of water will dash. If you pack sand in this 30-centimeter tube, 3 of them, you pack loamy clay soil here, sandy soil here, loamy soil here, and you allow them in water. You put them in what did the equation say? A beaker of water. You put this in beaker of water for 1 week. What will happen? Say the level of water will be dashed. A, lowest in the tube with clay. Lowest in the tube with clay. B, the same in all the tubes. C, lowest in the tube with loamy. D, lowest in the tube with sandy soil. What's the answer? Without the option self, in these 3 types of soil, which one? You put water inside beaker and place them in it. Now, which one will have the lowest level of water? From the question we answered, from that first question, you were supposed to get an idea of that. Lowest in what? Is that the correct answer? What is the correct answer? Sandy. Remember, sandy soil has the lowest capillary action. Clay soil have the highest capillary action. So clay soil, we have high next to loamy, and sandy soil we have the lowest, because the level of water absorption, the capillary action is very low in sandy soil because it's very porous. It cannot hold water for a long time. Do you get? But clay soil can hold water for a long time, so the capillary action here will be high. So the level will be highest in this and lowest in sandy soil. Do you get that? All right. Your question. A few grams of dried soil. Listen to it attentively. A few grams of dried soil were first heated until red hot, and then further heated until no more smoke was released. This experiment was to determine the dash. I don't want to give you option. Let me repeat the question. Please, everybody listen. A few grams of dried soil were first heated until red hot, and then further heated until no more smoke was released. This experiment was to determine the dash. Let me give you option. A, amount of water in the soil. B, percentage of water in the soil. C, presence of humus in soil. D, resistance of laterites to heat. Humus. Presence of humus in the soil. Is that correct? What is the answer? Wrong. She is correct. Is the amount of humus, presence of humus in the soil. Let me explain. The question says a few grams of dry soil was first heated until red hot, right? At that point, if you stop there, what you've driven out is water. So if you stop there, is the equation stop there, you know what you are looking out for is the percentage of water. But now you are further heating it until no smoke. That further heating, now you are burning all the organic compounds out. So after burning all the organic compounds, the humus out now, you can now do your calculations to get the amount of humus present. So if the question says you are heating the soil until red hot and you stop there, what you are looking for is percentage of water. But if you further heat it after red hot, you further heat the soil until no smoke. You know what is bringing out the smoke is all those organic compounds, decaying plants and animals. That's what is bringing out that is the humus. But if you continue to heat until no smoke is coming out again, it means you've removed all the humus present. So that is used to check the percentage humus in that soil. Do we understand? When we take calculations, we understand that better. Yes, your question now. Okay, the next question here is a calculation question, but since we've not done calculation, we'll take that together. But after this. Yes. If a handful of soil is shaken with water and left to settle, the soil particles will settle from light to heavy particles as follows. if a handful of soil, if you put soil inside a container and put water inside and shake it and allow it to stand, the soil particles will settle from light to heavy particles as follows. So I'll just list out the particles here, then you tell me how they will settle. So from these particles here, from light to heavy, tell me how they will settle. That's question number 6. Yes. So how will they settle? Okay, you said the first one is what? Sand. You said the first one is sand. Yes. Next one is what? Silt. Next one is what? No, it's not your turn. He is the one answering. The question says, if a handful of soil is shaken with water and left to settle, the soil particles will settle from light to heavy particles as follows. From the lighter one to the heavier one. So you are arranging from light to heavy. So okay, first, sand is not correct. What's the lightest particle here? What's the lightest particle here? Silt, clay that is heavy. Okay? Humus. Now, you've known that humus is okay. All the options here start from humus. So if you've known that humus is the lightest, you now check which one is starting with humus. But here they are wise, so all the options are starting with humus. All right. So the next one is what? No. I already arranged it for you. If you look at this, actually, the clay here, remember, the clay here is not the clay soil itself. The clay is in clay soil, the most abundant particle in clay soil is clay. Do you get? So the clay here is not clay soil, it's not the clay soil itself. Do you get? This is the lightest. Clay is still light. Silt, sand and stone. Of course, you should know that stone should be the heaviest. But if the option, wow, these people are wise. Option A ends with stone. Option B ends with stone. Okay, C did not end with stone. Then D ends with stone. You can actually check the one you know to check the one you don't. But this is the right arrangement from the lightest to the heaviest. So you can take note of this in your notes. It's all this past question we are doing. You're taking notes of them, please. Next question goes to who? Close that book. It's your turn. Water retention is highest in soils which are rich in dash. Says what? Clay. But the option says A, sand, poor in humus and devoid of clay. B says clay and sand. I laughing. Hold on. I take the question again. Water retention is highest in soils which are rich in dash. A, sand, poor in humus and devoid of clay. B, clay and sand but poor in humus. C, clay and humus but poor in sand. D, clay, poor in humus and devoid of sand. What's the answer? D, clay, poor in humus and devoid of sand. Because if humus is present and sand is present, it will make it porous. to make it not to retain water more. Do you get? Do you understand? The more the sun, the lesser the retention. The more the humus, the lesser the retention. So water retention will be highest in soil that is rich in clay, poor in humus, and devoid of sand. So that's the answer there. What's the next person? Yes, you're the next person. Samples of different soil types are packed in glass tubes whose lower ends are plugged with cotton wool. If these tubes are suspended in a tub of water, water will rise highest after a few hours in dash. Yes, it's you. Have you answered before? Okay, the answer is what? Clay, right? We know capillary action is highest in what? In clay. So the answer is clay. Yes, your turn now. Soil with the finest particles is called dash. Sister, is your turn now? Soil with the finest particles is called dash. Are you looking for the answer? So what's the answer? You must answer. It's by force. Clay with the finest particle is called what? I just told you the answer. You see? I just told you the answer. So the soil with the finest particle is called what? Clay. Clay have the smallest particle. If you take clay, I'm not sure you can even, if you take sand, you can actually bring them seed by seed. Is it not? But if you take clay, can you take them seed by? You cannot. It's very minute, very small. Do you understand? So the soil with the finest particle is what? When they say finest particle, it will not be the one with fine pass. All right, so your turn now. The water retention capacity of a soil indicates its dash. The water retention capacity of a soil indicates its dash. So that's your question. What's the answer? Capillary action or capillarity, right? So the answer is capillarity. Capillarity. Here's your turn. In a soil sample, the relative amounts of the different soil particles can best be determined by the process of dash. In a soil sample, the relative amounts of the different soil particles can be best determined by the process of dash. A. Filtration. B. Centrifugation. C. Precipitation. D. Sedimentation. So what's the answer? Sedimentation. Is sedimentation correct? Yes. Now, if you have mixture of different substances in the soil and you want to separate them, so you put it in the water, maybe spin it, stir it, and allow it to stand, right? And they will sediment based on their particle size, right? So the answer is what? Sedimentation. All right, next person. Yes, great. A soil consisting of alumina and iron 2 oxide is known as dash. A soil consisting of alumina and iron 2 oxide, if I were you, I will write it down, is known as dash. So what's the answer? A says loamy soil, B clay soil, C laterite, D podzol. You say? Clay soil. But when I explain, one cheat of knowing it, I know I did not mention this. One cheat of knowing it is, first, when I was explaining clay soil, loamy soil, sandy soil, I did not mention alumina, I did not mention what again? Iron 2 oxide. The answer is laterite. The answer is laterite. That's the answer there. It's not a type of soil, but they say a soil consisting of. They didn't say a type of soil. Do you get? They say a soil consisting of alumina and iron 2 oxide. So the answer is laterite. So please write this in your book. Laterite. As we go on, we'll see other types, other things. And I'll explain that. What's the next person? Yes. Precious, right? All right. The soil type that will be most difficult to plow in a wet season is one that is dash. Should I come again? The soil type that will be most difficult to plow, P-L-O-U-G-H, in a wet season is one that is dash. You say it's plough? How will you pronounce this thing as plough? So it's one that is what? Clay, right? You said clay, when it is wet, it will dry up, right, and becomes heavy and sticky. So it is the most difficult to cultivate. So the answer is what? Clay soil. Yes. The soil type that contains nutrients which are not readily available for plants is dash. Listen again. The soil types, where is it? Okay, 16. The soil type that contains nutrients which are not readily available for plants is called dash. See? Sandy soil is not readily available. No, that's not the answer. What's the answer? Close that book. Use it when you get home. So what's the answer to that question? The soil type that contains nutrients which are not readily available for plants is what? No. Clay soil is the answer. Clay soil contains nutrients that are tied up. It's not readily available. Erosion can easily take place in sandy soil because it's porous. In fact, you've heard of pushing of the soil, of the nutrients of soil, deep down the soil so that plants root cannot get to it. It's called what? The process whereby nutrients in soil is pushed down into the soil so that plants roots cannot get to the nutrients is called what? That process is called what? Let me see who is thinking fast. Say your mind. Disintegration. Wow. Please don't say your mind. Say leaching. Thank you. Leaching. Even person when no, don't shout. So it's called what? Leaching. Leaching. You are washing the nutrients is pushed down. Plants who cannot get to it, and that can easily take place in sandy soil because it's very porous. But clay soil, we die here. It's holding it. Do you get? So clay soil contains nutrients that is not readily available for plants. All right. Next question is who? Yes, you. The increasing order of the particle size in the following soil types is dash. So they put clay, sand, silt, gravel. So okay, stay on the wow. It means the answer is on the board. It means the answer is on the board. So what's the answer? Clay, silt, clay, sand, silt. Let me write them so you arrange them for me. Clay, sand, silt, gravel. So arrange them according to, say, the increasing order of particle size. So arrange them from the smallest to the highest for me. What will be the answer? What will be the answer? Clay, silt, sand, and gravel. So this is the correct answer. Good. Clay is from what we saw here: clay, silt, sand, then stone, gravel. So that's the answer. C is the correct option there. All right. So, yes, your turn. What's that your name? The soil with the highest water retaining capacity is dash. No option. The soil with the highest water retaining capacity is dash. Clay soil, is it correct? Okay, that's correct. Okay, so I still have some questions here, but let's go into calculation first so that we can do other things. So we'll be looking at calculations we can see in soil, and we're going to be calculating together. Is this set? All right, now we'll be looking at some calculations in soil chemistry. So the first question here, please listen attentively, because I will not be giving you formula. You know, one thing about this exam you're preparing for is accuracy and speed. Accuracy and what? You don't have all the time to be showing working. Some of you will not be arranging the working in your rock. They are not seeing any of those things. What they are interested in is take the right answer. So yeah, I'm not going to be giving you any formula. I'm going to be giving you the shortest way you can get your answer. So like this, you can look at it without solving one thing and you just pick the answer. I'm very serious about that. You can look at it, not be to shine eye. You can look at this and just pick your answer and go your way. All right, now let's go. The question says 28 grams of soil sample was heated to a constant weight of 24 grams. Listen, I would not like you to be talking now. Listen. When further heated to red hot and cooled, it weighed 18 grams. What is the percentage of humus in the soil? Remember that question we read before. First, you heated the soil to a constant weight. This first heating, what are you driving out? Water, right? Now you further heated the soil until red hot and cooled. What are you removing now? What are you heating out now? Humus, right? They are now asking the percentage of humus. Now, visualize this now. You went outside, you pack soil. Put in a container. You weigh the soil. The mass of the soil is equal to what? But this soil, does it contain water? This soil you pack contains water, right? So let me call it mass of wet soil is equal to what? 28 grams. Now you heated it to a constant weight of 24 grams. As you are heating it, what were you removing? Water, right? So what we are now having is dry soil, right? So mass of dry soil. Mass of dry soil is 24 grams. Good. Do you know that from here you can get the percentage water? But we are not going. Let's focus on the equation first. Now, when further heated to red hot and cooled, it weighed 18 grams. When further heated and cooled, it weighed 18 grams. Now, with this further heating, what were we removing? Humus, right? So let's say mass of soil without humus is equal to what? 18 grams, right? Now they say, what is the percentage of humus in the soil? Now pay attention. I want to do the magic now. The weight of the total soil, water plus humus plus everything, is 28 grams, right? You remove water, you now have this. So this is dry soil and humus. Now you further heated it and we now have what? 18 grams, right? Now, what they are now asking us the percentage of humus in the soil. But wait, what's the mass of humus in the soil? 6 grams. How do you get the 6 grams? Thank you. This is a dry soil. This soil contains, we've removed water, right? But there's still humus. Now you now heated it until humus finished. So now you now get this. That shows that the mass of humus will be equal to the mass of dry soil minus the mass of the soil without humus. So that will give us what? 6 grams. But they're asking us the percentage of humus in the total soil, right? So percentage of humus in the total soil, not in the dry soil, not in the soil without humus, in the total soil will be what? 6 divided by the mass of the total soil times what? 100. Because they say percentage, that's why we're multiplying by 100. So 6 divided by this times this will give us what? 21 point what? 21.4%, right? Good. Now check your option. Here we have 22.2, 55.6, 75.0, 25. So 21.4 is not in the option. What will you do? You choose the one that is closest to your answer. Because you've done the right thing and it's not there. So our answer becomes A. So anytime you solve something like that and you're not seeing exactly your answer, choose the one that is closest. What we did here was, you just look at, you put, this is a container that have soil. This soil have water. This soil have humus. The first thing you did was you heated it to remove water. So this soil now contains soil plus humus. You heated it again to remove humus. This soil now contains only soil. Now they are now asking you the percentage of humus. Percentage of humus. The mass of humus, first of all, is this one minus this one. Then the percentage, you now do over the total mass of soil times 100. So write this down. Alright, now let's look at the second question. The initial volume of water poured into a bag of dry soil was 50 ml. And the amount that drained was 35 ml. The percentage water content of the fully soaked soil is therefore dash. Now look at this. You have something like this. The initial volume of water poured into a bag of dry soil. You have dry soil here. Dry soil. Then you now pour 50 ml of water here. Then this bag is porous. So some of the water was draining out, just pouring out. And we said that how many ml of the water drained? 35 ml of the water drained out, right? So 35 ml drained out, poured out. So how many ml was retained by the soil? Remember 50 ml was poured there, right? And some of them were draining out. We say 35 ml drained out. So how many ml was retained? So if you want to check the one that was retained, it's just 50 minus what? 35. It's just like 1,000 entered your hand. And as 1,000 entered your hand now, 200 now fall out. How much is remaining? 800. As I use money now, and I understand a bit. So 50 ml of water was poured into dry soil. 35 ml drained out. It means the amount of water that was retained by the fully soaked soil is what? 15 ml. Now they are asking us the percentage. The percentage now, you know, when we're talking about the percentage, we are now relating it to the total amount, right? So it will be what? 15 over what? Over 50. The amount of water we pour times what? 100. This will give us what? 30.0%. D. You see that you don't even need solving. Just understand with your spiritual eye, no biological eye. Is it? Alright, but just understand with your one of your eyes. And you take your answer and go your way. 5 grams of oven dried soil. The soil is already dry. Was heated in a furnace for 24 hours. After cooling, it weighed 4.8 grams. What is the amount of humus in the soil? The options were given in percentage. Now, mass of dry soil is equal to what? 5 grams, right? Because this is dried already. It's oven dried, no water. In this question, can you calculate percentage water? You cannot, because the mass of wet soil was not given. Now, after heating this, further heating of this dry soil, you got what? 4.8 grams, right? This further heating after drying, what are you removing? Humus, right? So mass of soil without humus is equal to what? 4.8 grams, right? So if the mass of the dry soil, this one is still with humus is 5, and without humus is now 4.8. What will be the mass of humus? Mass of humus becomes 5 minus 4.8, right? Which is what? 0.2 grams. But now the amount in percentage will now be what? 0.2 over what? The total weight, right? 0.2 over what? 5 times what? 100, which will give us what? 4%. So humus is just 4% of the soil sample, of the dry soil sample. So that's the answer. Now let's look at the fourth question. A crucible of 5 grams weighed 10 grams after filling it with fresh soil. It is then heated in an oven for 1 hour. After cooling in a desiccator, the weight was 8 grams. The percentage of water in the soil is dash. Alright, now look at this. A crucible, like a container where they put the soil to heat. So a crucible, what's the weight of the crucible? Weight of crucible is equal to 5 grams. And they said a crucible of 5 grams weighed 10 grams after filling it with fresh soil. So here, weight of crucible plus soil is what? 10 grams, right? Now look at this. The weight of the crucible alone, the container alone is 5 grams. You now put soil inside the container. The total weight becomes what? 10 grams. So if the container alone is 5 grams, the weight of the soil will be what? Will be 10 minus 5, right? Which is what? 5 grams. So weight of soil is 5 grams. Do you understand? The container alone is 5. The container plus the soil is 10, meaning the soil alone is 5. Now, it is then heated in an oven for 1 hour. After cooling in a desiccator, the weight was 8 grams. The weight of the container and the soil is now 8 grams after heating in a desiccator, in an oven, after heating. So we already know that the weight of the container was what? 5. Heating will not reduce the weight of the container now. Is it not? So after heating, and during heating, what are we removing? Water, right? So after heating, weight of soil will become what? What will be the weight of the soil after heating? After heating and cooling now, after we heated it so it will be 3, right? Because the weight of the soil and the crucible after heating is 8 grams. Meaning the weight of the soil, we already know that the weight of the crucible is what? 5 grams. So weight of the soil after heating and cooling will be 8 minus 5, which is what? 3 grams. This 8 is the weight of the crucible plus the heated soil, the dry soil now. This 5 is the weight of this crucible. So we have 3 grams. Now we are asked the percentage of water in the soil. Wet soil is what? 5 grams, right? Dried soil is what? 3 grams. So if wet soil is 5 grams and dry soil is 3 grams, it means the mass of water in it was what? Is equal to 5 minus 3, right? Which is what? 2 grams. So percentage of water in the soil will be 2 over what? 5, not 10. That's the mistake most of you make. The 10 here is crucible plus soil, but the soil alone is 5. So 2 over 5 times 100, which will give us what? 40%. That's the answer to that question. Alright, so this is a classwork. Mass of a crucible is 10 grams. Mass of crucible and soil before heating 29 grams. Mass of crucible and soil after heating 18 grams. From the information, determine the percentage of water in the given soil sample. So, those of you following online, you solve this question. This is not the answer. You solve this question and drop your answer in the comment section. So, please solve that very